American 191, contact departure, good day. Those were among the last routine words exchanged before one of aviation's most horrifying disasters unfolded in broad daylight at Chicago's O'Hare International Airport on May 25, 1979. What started as a normal Friday afternoon departure would become a nightmare that changed commercial aviation forever. As 271 souls aboard American Airlines Flight 191 faced an unimaginable terror when their aircraft's left engine literally ripped away from the wing during takeoff, sealing their fate in the most devastating way possible. The sight of that massive General Electric CF6 engine tumbling across the runway while the DC-10 climbed helplessly into the sky remains one of the most chilling images ever captured in aviation history. A frozen moment of mechanical failure that would expose deadly flaws in both aircraft design and maintenance procedures that had been lurking in the shadows for years. The morning of May 25th dawned bright and clear across the Midwest, with perfect flying weather greeting passengers and crew members preparing for what should have been a routine Memorial Day weekend flight from Chicago to Los Angeles. American Airlines Flight 191 was operated by a McDonnell Douglas DC-1010, registration N110AA, a wide-body trijet that had been delivered to American Airlines just over 8 years earlier and had accumulated over 20,000 flight hours in service. The DC-10 was considered a marvel of engineering at the time, capable of carrying up to 380 passengers across transcontinental distances with its 3 powerful engines and spacious cabin design that promised comfort and reliability for long-haul travel. The aircraft itself had an impressive safety record up to that point, with thousands of DC-10s operating worldwide without any major incidents that would suggest the catastrophic failure that was about to unfold. Captain Walter Lux, 53 years old, with over 22,000 flight hours under his belt, was an experienced aviator who had been flying for American Airlines since 1963 and was well respected among his peers for his professionalism and attention to safety. His colleagues described him as a meticulous pilot who never cut corners and always insisted on following proper procedures, making the events that were about to unfold even more tragic, given his commitment to aviation safety. First Officer James Dillard, 49 years old with more than 9,000 flight hours, served as co-pilot alongside flight engineer Alfred Udovich, 56 years old with extensive experience on the DC-10 type, and a reputation for his thorough knowledge of the aircraft's complex systems. The cabin crew consisted of 9 flight attendants led by senior purser Melody Smith, all of whom had been thoroughly trained in emergency procedures and passenger safety protocols, representing years of combined experience in handling everything from routine service to crisis situations. Among the 258 passengers boarding that afternoon were families heading to California for vacation, business travelers returning home after successful deals in Chicago, and individuals visiting loved ones for the holiday weekend, each carrying their own dreams, hopes, and plans for the days ahead. There was the young couple celebrating their first wedding anniversary with a trip to Disneyland, the businessman who had just closed the biggest deal of his career and was eager to share the news with his family in Los Angeles, and the grandmother who was traveling to see her newest grandchild for the first time. These ordinary people, living ordinary lives, had no way of knowing that they were about to become part of one of aviation's most studied and remembered tragedies, their personal stories forever intertwined with the technical failure that would claim their lives. The aircraft had undergone routine maintenance just weeks before the accident, including work on the left engine pylon assembly that connected the massive CF6 engine to the wing structure. This maintenance procedure involved removing the entire engine and pylon assembly as a single unit using a forklift, a practice that was considered more efficient than removing the engine and pylon separately as recommended by the manufacturer McDonnell Douglas. What the maintenance crews and airline management didn't fully understand at the time was that this shortcut procedure placed enormous stress on the critical rear attachment point of the pylon, causing microscopic cracks to form and propagate over time in ways that were completely invisible during routine visual inspections. The aluminum fitting that connected the pylon to the wing's rear spar had been weakened beyond its design limits, creating a catastrophic failure point that was ticking like a time bomb, waiting for just the right combination of forces and stresses to trigger complete structural failure. Investigation would later reveal that several other DC-10 aircraft in American Airlines fleet had similar damage to their pylon assemblies, suggesting this was not an isolated incident, but rather a systemic problem created by improper maintenance procedures that violated the manufacturer's specifications and had been going on for months or even years. The discovery of these additional damaged aircraft would send shockwaves through the aviation industry and raise serious questions about how such a widespread safety issue could have gone undetected by both airline management and federal regulators, who were responsible for ensuring that proper maintenance procedures were being followed. As Flight 191 pushed back from Gate K5 at O'Hare's Terminal 3, the atmosphere in the cockpit was relaxed and professional, with the crew running through their normal pre-flight procedures and checklists with the practiced efficiency that comes from years of experience. The weather was perfect for flying, with clear skies, light winds, and excellent visibility that promised a smooth departure and climb out from one of the world's busiest airports. The aircraft taxied to runway 32R, one of O'Hare's longest runways at over 13,000 feet, providing more than adequate distance for the DC-10's takeoff requirements even under the most challenging conditions. Ground control cleared them to the runway without delay, and the crew completed their final checks as they prepared for what should have been a routine departure to the West Coast. At 3:02 p.m. Central Daylight Time, the crew received clearance for takeoff from O'Hare Tower, and Captain Lux acknowledged the clearance with his characteristic professionalism before advancing the 3 throttles forward, beginning the takeoff roll that would become a nightmare beyond imagination. The massive aircraft accelerated down the runway with its characteristic rumble, the 3 General Electric CF6 engines generating over 120,000 pounds of thrust as it gained speed toward the critical V1 decision speed of 159 knots, the point beyond which a takeoff could not be safely aborted. Passengers settled back in their seats, many gazing out the windows at the familiar sight of Chicago's skyline growing smaller below, completely unaware that their aircraft was carrying within it the seeds of its own destruction. Children pressed their faces to the windows in excitement. Parents double-checked their seatbelts, and business travelers opened their newspapers, all of them trusting in the skill of their crew and the reliability of their aircraft. The left engine pylon, already weakened by improper maintenance procedures performed weeks earlier, was being subjected to the enormous forces and vibrations of takeoff, causing the hidden cracks in the rear attachment point to spread rapidly through the critical aluminum structure that held the massive engine in place. With each second of acceleration, with each vibration transmitted through the airframe, those microscopic fractures grew larger and more dangerous, racing toward the critical point where the structure would no longer be able to withstand the tremendous loads being placed upon it. The crew had no way of knowing that their aircraft was literally coming apart beneath them, no warning systems or indicators that could alert them to the catastrophic failure that was developing in real time as they hurtled down the runway. At approximately 3:03 p.m., as Flight 191 reached a speed of about 159 knots, and Captain Lux began to pull back on the control yoke to rotate the aircraft for liftoff, the unthinkable happened with terrifying suddenness. The left engine's rear pylon attachment failed completely in a cascade of structural collapse, causing the entire 8,500-pound General Electric CF6 engine to pitch upward and rip away from the wing in a shower of sparks, hydraulic fluid, and debris that scattered across the runway like deadly confetti. Witnesses on the ground watched in horror as the massive engine tumbled across the runway like a discarded toy, leaving a trail of destruction in its wake, while the DC-10 continued its climb into the sky, now critically damaged and doomed to a fate that no amount of skill or training could prevent. The separation of the engine caused catastrophic damage to the aircraft's systems that went far beyond the simple loss of 1/3 of the airplane's thrust. The violent departure of the engine severed hydraulic lines that controlled the left wing's leading-edge slats, critical aerodynamic devices that helped maintain smooth airflow over the wing at low speeds and high angles of attack. Even more devastating, the engine's departure disrupted electrical systems that powered critical flight instruments, leaving the crew with incomplete and potentially misleading information about their aircraft's condition at the moment when they needed accurate data. Most desperately. The engine's separation also damaged the left wing's structure and altered its aerodynamic properties in ways that made controlled flight virtually impossible, though the crew had no way of understanding the full extent of the damage from their position in the cockpit. Captain Lux and his crew found themselves in an unprecedented emergency situation with no time to analyze what had happened and severely limited information about the true extent of their aircraft's damage. The flight manual and emergency procedures they had trained with countless times had never addressed this specific type of emergency, leaving even these experienced professionals without the knowledge they needed to understand what was happening to their aircraft. The cockpit voice recorder would later capture the crew's confusion and growing concern as they struggled to understand why their aircraft was not responding to control inputs in the expected manner, their voices remaining calm and professional even as they faced a situation that was rapidly spiraling beyond their ability to control. The loss of the left engine and the damage to the wing's leading-edge slats created an asymmetrical stall condition that was impossible for the crew to detect or correct with the information available to them in the cockpit. The left wing, now missing its leading-edge slats due to the hydraulic system failure caused by the engine separation, began to stall at a much lower angle of attack than the right wing, which still had its slats functioning normally. This created an aerodynamic imbalance that caused the aircraft to roll uncontrollably to the left, despite the crew's desperate attempts to maintain wings-level flight using the controls available to them. The DC-10's flight manual and training procedures had never addressed this specific combination of failures, leaving the experienced crew without the knowledge they needed to understand that their aircraft had entered a flight regime from which recovery was impossible. Captain Lux instinctively pulled back on the control yoke in a natural attempt to maintain altitude and prevent the aircraft from descending, unknowingly increasing the angle of attack and worsening the asymmetrical stall condition that was already developing on the damaged left wing. This response, while completely understandable and consistent with normal emergency procedures, actually accelerated the onset of the uncontrollable roll that would ultimately doom the aircraft. The flight data recorder showed that the crew made repeated attempts to level the wings and maintain control, their inputs becoming more desperate as they realized that their aircraft was not responding to normal control techniques. In the cabin, passengers began to sense that something was terribly wrong as the aircraft's motion became increasingly erratic, and the normal sounds of flight were replaced by ominous groaning and vibration. Less than a minute after takeoff, Flight 191 had rolled past 90 degrees and was descending rapidly toward the ground, its massive fuselage cutting through the air in an unnatural attitude that defied every principle of controlled flight. The aircraft was now in what accident investigators would later describe as an unrecoverable flight condition, with the asymmetrical stall and structural damage making it impossible for even the most skilled crew to regain control. Passengers who moments before had been settling in for a comfortable cross-country journey now found themselves trapped in a metal tube that was falling from the sky, experiencing forces and sensations that no human being should ever have to endure. The aircraft's public address system remained silent as the crew fought desperately with the controls, focusing every ounce of their skill and experience on trying to save their aircraft and the lives of everyone aboard, even as the situation continued to deteriorate beyond any hope of recovery. In the cabin, flight attendants struggled to maintain their footing as the aircraft rolled and pitched violently. The familiar environment of the passenger cabin transformed into a scene of chaos and terror as loose objects became projectiles and the normal rules of physics seemed suspended. The professional training that had prepared them for various emergency scenarios could not have anticipated the extreme conditions they now faced, yet these dedicated individuals continued to try to help and reassure passengers even as their own world literally turned upside down. Parents clutched their children, strangers reached out to comfort one another, and in those final moments, the arbitrary barriers that normally separate people dissolved in the face of shared humanity and impending tragedy. At 3:04 p.m., just 31 seconds after takeoff and less than a mile from the departure end of runway 32R, American Airlines Flight 191 impacted an open field near a mobile home park in Des Plaines, Illinois, striking the ground in a left-wing low attitude at tremendous speed. The impact was catastrophic and instantaneous, creating a fireball that could be seen for miles as 100,000 pounds of jet fuel ignited in a massive explosion that incinerated the aircraft and claimed the lives of all 271 people aboard. The force of the impact was so tremendous that the aircraft was almost completely destroyed, leaving investigators with limited physical evidence to work with as they began the painstaking process of determining exactly what had caused this unprecedented disaster. 2 people on the ground were also killed when debris from the aircraft struck their mobile home, bringing the total death toll to 273 and making Flight 191 the deadliest aviation accident in United States history at that time. The investigation that followed would revolutionize aviation safety and expose fundamental flaws in both aircraft design and maintenance procedures that had been hidden for years beneath the veneer of routine operations and acceptable safety records. Led by the National Transportation Safety Board, under the direction of experienced investigators who had seen many aviation accidents but nothing quite like this, the team spent months piecing together the sequence of events that had led to the catastrophic engine separation. They examined every piece of wreckage that could be found, interviewed hundreds of witnesses, maintenance personnel, and aviation experts, and conducted extensive testing to understand exactly how and why the pylon attachment had failed so catastrophically. The investigation was complicated by the extensive fire damage and the fact that the critical pylon attachment hardware had been severely damaged in the impact, requiring investigators to use advanced metallurgical analysis and computer modeling to reconstruct the failure sequence. The breakthrough came when investigators discovered the fractured rear pylon attachment fitting among the wreckage and realized that the failure had been caused by improper maintenance procedures rather than a manufacturing defect, design flaw, or random mechanical failure. The practice of removing the engine and pylon as a single unit using a forklift, while more efficient from a maintenance standpoint and seemingly logical from an operational perspective, placed enormous stress on the rear attachment point that was never intended to bear such concentrated loads. This stress caused fatigue cracks to develop and propagate over time until catastrophic failure occurred under the normal operating loads experienced during takeoff. Even more disturbing was the discovery that this maintenance procedure was being used by other airlines as well, raising the specter of additional DC-10 aircraft flying with potentially damaged pylon attachments that could fail at any time without warning. The Federal Aviation Administration took the unprecedented step of grounding all DC-10 aircraft worldwide pending inspection of their engine pylon attachments, a decision that sent shockwaves through the aviation industry and raised serious questions about the certification and oversight processes that had allowed these maintenance procedures to continue unchecked for so long. This emergency airworthiness directive affected hundreds of aircraft and thousands of flights, causing massive disruption to airline schedules and forcing carriers to lease or borrow aircraft from other operators to maintain their route structures. The grounding also raised uncomfortable questions about how such a fundamental safety issue could have escaped the attention of both airline management and federal regulators, who were supposedly monitoring maintenance practices and ensuring compliance with approved procedures. Investigators found similar damage on several other American Airlines DC-10s during the mandatory inspections that followed the grounding, confirming that Flight 191's accident was not an isolated incident, but rather the visible manifestation of a systemic problem that could have affected any number of aircraft in the fleet. The discovery of these additional damaged aircraft was particularly disturbing because it demonstrated that the improper maintenance procedure had been used multiple times and that other aircraft could have suffered similar catastrophic failures if the accident had not occurred when it did. This finding led to a complete review of maintenance procedures not just for the DC-10, but for all commercial aircraft types, as regulators and manufacturers worked to identify any other areas where shortcuts or unofficial procedures might be compromising safety. The investigation also revealed critical gaps in pilot training and aircraft design that had contributed to the crew's inability to understand and respond effectively to the emergency they faced. The loss of the left engine had disabled not only the hydraulic systems that controlled the leading-edge slats, but also some of the cockpit warning systems that might have alerted the crew to the true nature of their emergency. Even more problematic was the discovery that the specific combination of failures that occurred on Flight 191 had never been considered during the aircraft's certification process, meaning that neither the manufacturer nor the regulatory authorities had fully understood the potential consequences of this type of failure. This gap in understanding had resulted in flight manuals and training programs that did not prepare crews for the unique challenges posed by an engine separation combined with hydraulic system failures and asymmetric slat deployment. McDonnell Douglas, the manufacturer of the DC-10, faced intense scrutiny over the aircraft's design philosophy and the adequacy of its emergency procedures, while American Airlines and other carriers were forced to completely revise their maintenance procedures to prevent similar failures in the future. The manufacturer had to answer difficult questions about why the aircraft's systems were not designed to be more fault-tolerant, and why the emergency procedures did not adequately address the type of multiple system failures that occurred on Flight 191. The company ultimately made significant design changes to improve the DC-10's emergency handling characteristics, and worked with airlines and training organizations to develop better emergency procedures and simulation scenarios that would better prepare crews for unusual situations. The accident led to significant changes in how engine pylons are maintained throughout the industry, with new procedures that require engines and pylons to be removed separately to avoid placing excessive stress on critical attachment points. These new maintenance procedures were more time-consuming and expensive than the shortcuts that had been used previously, but they eliminated the risk of causing hidden damage that could lead to catastrophic failures. Aircraft manufacturers were also required to improve their emergency procedures and training materials to better prepare crews for unusual emergency situations, while the FAA strengthened its oversight of airline maintenance practices and began requiring more detailed inspections of critical aircraft components. The regulatory changes that resulted from the Flight 191 investigation represented some of the most comprehensive safety improvements in aviation history. The DC-10 itself underwent significant modifications to improve its emergency handling characteristics and to provide crews with better information about aircraft systems failures, including improved warning systems and revised flight control software that made the aircraft more predictable in emergency situations. These improvements, combined with the enhanced maintenance procedures and better pilot training, helped restore confidence in the DC-10 design and allowed the aircraft to continue serving successfully for many more years. However, the reputation of the DC-10 was permanently affected by the Flight 191 accident and several other high-profile incidents, ultimately contributing to the decision to end production of the type in favor of more modern designs. The human cost of Flight 191 extended far beyond the 273 lives lost that day, touching the families, friends, and colleagues of everyone who perished in the tragedy in ways that continue to resonate decades later. Among the victims were parents who would never see their children grow up, children who would never return to their families, and countless individuals whose potential contributions to society were cut tragically short by a preventable accident that should never have happened. The crew members who died that day were experienced professionals who had dedicated their careers to aviation safety, and their loss was felt deeply throughout the airline industry, where their colleagues struggled to understand how such skilled individuals could be placed in an impossible situation through no fault of their own. Captain Walter Lux left behind a wife and family who had supported him throughout his flying career, sharing the pride and challenges that came with being married to a professional pilot in an era when aviation was still developing its modern safety culture. First Officer James Dillard and Flight Engineer Alfred Udovich were remembered by colleagues as skilled airmen who took pride in their work and had earned reputations as thorough, safety-conscious professionals who could be counted on to do their jobs correctly under any circumstances. The 9 flight attendants who perished were young men and women who had chosen careers in aviation because they enjoyed helping others and seeing the world. Their lives ended far too soon by circumstances completely beyond their control, and despite their professional training and dedication to passenger safety. The investigation into Flight 191 also revealed important lessons about the complex relationships between aircraft manufacturers, airlines, maintenance organizations, and regulatory agencies that govern aviation safety in ways that are often invisible to the traveling public. The pressure to minimize aircraft downtime and reduce maintenance costs had led to the adoption of procedures that seemed more efficient but actually compromised safety in ways that were not immediately apparent to those making operational decisions. The accident demonstrated the critical importance of following manufacturer recommendations exactly, even when alternative procedures might seem more practical, cost-effective, or logical from an operational standpoint. It also highlighted the need for better communication between manufacturers and operators regarding the potential consequences of deviating from approved maintenance procedures and the importance of thorough testing and analysis before implementing any changes to established practices. In the years following the accident, significant improvements were made to aircraft design, maintenance procedures, and pilot training that have helped prevent similar tragedies from occurring and have contributed to the remarkable safety record that commercial aviation enjoys today. Modern aircraft are equipped with more robust warning systems that provide crews with better information about system failures, while maintenance procedures have been standardized and subjected to more rigorous oversight by both airlines and regulatory authorities. The lessons learned from Flight 191 have been incorporated into training programs for pilots, mechanics, and other aviation professionals around the world, ensuring that future generations of aviation workers understand the critical importance of following proper procedures and maintaining the highest standards of safety in every aspect of their work. The accident also led to improvements in aircraft certification processes, with regulators now requiring more extensive testing of aircraft systems and emergency procedures before new types are approved for service, including consideration of multiple system failures and unusual emergency scenarios that might not have been anticipated during the original design process. These enhanced certification requirements have resulted in aircraft that are more fault-tolerant and better able to handle emergency situations, while improved training requirements have ensured that crews are better prepared to respond effectively to the challenges they might face in actual emergency situations. Today, as we remember the victims of American Airlines Flight 191, we must acknowledge both the terrible price that was paid for these safety improvements and the commitment of countless aviation professionals who have worked tirelessly to ensure that such a tragedy never happens again. The families of those who died have established memorial funds and scholarship programs to honor their loved ones' memory and to support future aviation safety research, turning their grief into a force for positive change that continues to benefit aviation safety today. These memorials serve not only as tributes to those who were lost, but as reminders of the ongoing responsibility that all aviation professionals share to learn from past tragedies and to never become complacent about safety. The site of the crash in Des Plaines has been marked with a memorial that serves as a reminder of the human cost of aviation accidents and the ongoing need for vigilance in maintaining the highest standards of safety throughout the aviation industry. The memorial includes the names of all 273 victims and serves as a place where families and friends can come to remember their loved ones and reflect on the importance of aviation safety. Every time you board an aircraft today, you benefit from the lessons learned from Flight 191 and the dedication of those who refuse to let these deaths be in vain, working instead to create positive change that has made flying safer for everyone. The legacy of Flight 191 extends beyond the specific technical improvements that resulted from the investigation, serving as a powerful reminder that aviation safety is not something that can be taken for granted, but must be continuously earned through attention to detail, adherence to proper procedures, and a commitment to learning from past mistakes, regardless of how painful those lessons might be. The accident demonstrated that even experienced crews flying well-maintained aircraft can face situations that are beyond their ability to control, emphasizing the importance of designing aircraft and procedures that can accommodate human limitations and unexpected failures while providing multiple layers of protection against catastrophic outcomes. If this investigation into one of aviation's darkest days has moved you, please take a moment to like this video and subscribe to our channel, where we continue to explore the stories behind aviation's most significant accidents and the lessons they teach us about safety, human nature, and the ongoing quest to make flying as safe as possible. Share this story with others who might benefit from understanding how tragedy can be transformed into progress and how the sacrifice of those who died continues to protect travelers around the world. The memory of the 273 people who lost their lives aboard Flight 191 lives on in every safety improvement, every training program, and every procedure that helps prevent similar accidents from occurring, proving that even in our darkest moments, the human spirit's commitment to learning and improvement can create lasting positive change that honors those we have lost.